Hello everyone, this is our third practice problem updated. I apologize if you already looked at the other explanation that was old, but this is the more updated version that matches what the problem was for the practice. We have these expenditures for calculating. First of all, we have a self-constructed asset that is a landfill. We have some costs, some expenditures, and I've done it by taking the expenditure times the percentage of the year that it is outstanding, and then as the amount is paid, then it goes up. So it was 1.2 million for 25% or 3 months of the year. Then it went up to 1.9 million with the additional expenditure of 700,000, and that 1.9 million is for 5 12s or 5 months of the year, and then it goes up to the 3.4 with another payment out of 1.5 million for 2 12ths, and then the last is for 1 12th. So we multiply by the percentage of the year, add it up, and we get $2.133333 million as the weighted average expenditures. We have a line of credit for 2 million. That is going to be at 4%. That is specifically for our particular construction, and so the interest expense on that is 80,000. But our weighted average is higher than the specific borrowing, so we go to the other loan that we have outstanding, which is at 5% for the additional 133,000. Multiply that by 5%, take the $6,600 here, add it together, and that's our total interest that would be capitalized. If we were making journal entries, that would be a debit to the asset and a credit to probably interest expense, because as you paid interest through the year, you were debiting probably interest expense. So our total cost is, adding up all the actual direct expenditures to build this thing, 5.7 million, and the interest on top of that, we get 5.786666, and then we calculate the ARO, or the asset retirement obligation, because we have to put this back the way it was, and to get that we take the present value at 4%, and you could have perhaps used 5% here and you would get a different number, and it wouldn't be wrong. You find some interest rate in the problem that would indicate that that's what their borrowing rate is. That's what you should use. So in this case, it's $2 million at the end of 40 years. There's not a series of payments. It's just one payment at the end of 40 years. So we do that with this present value formula. Calculate the asset retirement obligation. So our total cost would be 6.203,245. That would be what your asset would be listed for. You would have an asset retirement obligation liability of this number, and then of course this is the interest came from interest expense, and the 5.7 would have been paid out in cash, so to make it all work out. So then we depreciate this for 10 years over a 40-year lifespan. 10 years we divide by 40. We're gonna have no salvage value because you have an ARO. You don't have a salvage value, but you're using the total of the two to do your depreciation, both the cost and the ARO. Now, correspondingly, you would also be increasing your ARO every year for 10 years, but that wasn't part of the problem in this case. We were not looking at that side. We're just looking at the fact that we have depreciation, so our carrying amount after 10 years is 4.6 million. We have a situation where we have to evaluate change in use, have to evaluate it for impairment. We're going to rent it out, but we get a pretty good rate for $19,500 a month times 12 times 25. okay, future years, is going to 5.85 million. That's higher than the carrying value, so there is no impairment. We do not have to go further. If you did, then of course you would take the present value of those future payments at the higher interest rate and to figure out what your new fair value is, and you'd have a loss. So, but that's not needed here in this situation because there was no impairment. So you were done with just comparing the carrying value to the future cash flows.